Howdy, everybody. Hope everything's going well with you wherever, whenever you are. Um, just wanted to continue working on solving the advent of code problems. So, if you recall from previous videos, we're trying to go from the beginning to the end. So today we're going to do day 4 of the year 2015. That's right here, the ideal stocking stuffer. Um, Before we get started, though, love your comments. If you have suggestions or ways to improve my code, I'd love to see them. But also just how did you solve it? Let's see how you solved it. Maybe you're not using Rust or you're using some other language. Um, I know it's a lot of fanboys are into Zig as well. I've seen a lot of people do some stuff in Zig. So anyway, whatever you're interested in, I'd love to see it. But in that light, just harkening back to a previous day, this is day 2. I got a comment that I thought was actually exactly what I was looking for. If you remember, this was like trying to, you had like packages, and I think part 2 it was ribbon, that you're trying to find like the area of a ribbon to figure it out. And then you wanted to, like, the 2 smallest pieces of ribbon were the ones that you were going to use. And for me, what I did was I just said, oh, I'm just going to sort them, and then I'll use, now that I have them sorted, I know the first and the second values are the smallest, and then I can use those for the calculation. And this was a perfect idea to use math and like what I was talking about, right? So instead of sorting them and then just using the first 2, you don't actually have to sort at all, because there's 3 values. If you just sum them up and then sum all of them up and then subtract the largest value, that will allow you to, get the 2 smallest values. And so that's the math that's happening right here. You can see I sum up parts 1, 2, and 3, and then I just subtract the max of the 3 values. And this, again, just because sort, I mean, again, this is very small, so sort is probably not that inefficient, but this allows you to do it somewhat programmatically, right? Because you're literally just saying find the 3 biggest and subtract it from the sum of all 3 of them, and that will get you the 2 smallest. So I hope I explained that okay and that made sense. But I think in the previous video I was like, is there some kind of, there's probably some kind of math I can do to get this answer and not have to worry about it. And sure enough, a commenter gave me that. So love your feedback. Thanks for sharing that stuff. And with that, we'll move on to day 4. The ideal stocking stuffer. Santa needs help mining some Advent coins, very similar to Bitcoins, to use as gifts for all the economically forward-thinking little girls and boys. To do this, you need to find MD5 hashes in hexadecimal, starting with at least 5 zeros. The input to the MD5 hash is some secret key, your puzzle input given below, followed by a number in decimal. To mine Advent coins, you must find Santa the lowest positive number, no leading zeros, 1, 2, 3, that produces such a hash. Okay, so this is actually the way that Bitcoin works. I don't know if you're aware. I actually, somewhere lost in time, I have like some amount of Bitcoin. I think it's not quite a whole Bitcoin, but it's pretty close to it. But I don't have the password to it. So, but the way that it works is the way that you used to do mining. Well, I presume you still do it this way, but when I was really into it, the way that you would do the mining was you would generate hashes of the transaction, and the goal was to find a hash that fits something along this lines. I don't think it was just 5. It was a huge block, but that was the idea behind mining, is everyone was trying to find that hash, and then whoever found that hash would get some amount of Bitcoin. Back in the day, it was a ton. It was like 50, I think. And so we were in groups where like there was like, I don't know, 30 or 40, 50. I don't remember how many there were, but we would all mine together and then we would share the results. And that's where I ended out with some. It wasn't even a whole Bitcoin. I guess, though, Bitcoin's probably pretty expensive now. It might be worth. The problem is you can see up here I use like Bitwarden, and so I'm sure I just used some very difficult password I'd never be able to remember or even try. Anyway, what can you do? Okay, so let's get back to this. So we're gonna MD5 and try and find some secret key that produces 5 zeros. So if our secret key was ABCDEF, the answer is 609043 because the MD5 of this starts with 5 zeros. And then it just gives you another example. Okay, so I presume we're just going to iteratively hash through these values until we find the right one. My inclination is that like part 2 is going to make that harder. Like maybe instead of 5, you have to do 10 or whatever. We might have to like heat up the room by doing some multi-processing. But anyway, let's just, I actually don't know. MD5 crate. Is that really right? Is it really MD-5? This one has a bunch. Updated 2 months ago, MD-5. I mean, okay. MD-5 does look like it's more popular. So let's look at the documentation really quick just to see how you would use it. You create a hasher, then you pass the message to the hasher, and then you finalize it and you get a result. We do want to dehexify it. Actually, do we need to dehexify it? Like, we want to get the first 5 of them to be 0. So we may just be able to like check some lower order bits. Let's try it and see how far we get. So we need to, first of all, we need to we'll add MD5. Are any of those worth using? Let's just go look at this and see what fields it has or anything. Sorry, I just want to kind of look around, see. Finalize gives you an array. Okay. Yeah, we'll use this. I don't know if we need the hex literal yet. That might be easier in the long run, but let's just do this right now. Oh, I should look what is my input. It's just a single string, so I'm kind of more inclined to put it right in here. Like this. I guess I don't have to. I can still use it like this, right? And we'll just say for each of these we'll have to do something like what is it? Strip. Wait, something about white space. Oh, maybe it's just trim. Is that right? Whites, yeah, trim leading and trailing white space. That'll be perfect. Okay, so we'll want to do that for both. Um, and then I think we just want to use the MD5. So let's create a. It does have a reset, so I think we can probably use a single hasher. So we can do like this and just, we're starting at 1, right? Okay. Oh, does this, what? Oh, I probably had to include digest because it's the type. This returns a type digest. Okay. Um, so we'll just do hasher.reset, and then we'll do hasher dot write input, and then hasher dot write what is it called? Uh, there's a function you can use, like it's s print. It's the equivalent of s printf. Um, format. I'm recording, buddy. Like this. So that will write the input. Was it not called write? You convert it to bytes. So it's update, and then we call let result equal hasher.finalize. It doesn't like me doing it that way? Okay. I presume I would be able to reuse it, but doesn't like me for some reason. Um, okay, so let's then. I'm kind of curious. Just we know which one starts with has the 0th one for A B C D E F. So just for testing purposes, I'm kind of want to do this and start at this one. And then break. Just to see what it looks like. Oh, I need to do this maybe. Okay. So let's just see what it looks like. So it wants to know the first 5. Like in what, imagine what that would be. So these are 8 bits. Yeah, it might, I don't know, converting to a string might make it easier. My thinking is like, how am I going to figure out which 5 are blank? Like this represents 2, this represents 2. And then the first part of this represents the 5th, right? So I wonder if we can use this hex literal to like get the hex of the value. Can you do the opposite? That's great. For converting hexadecimal string literals to a byte array, compile time. Oh, I actually want the opposite. Oh, okay. That's dumb. I can just use the format. Yeah, I probably should have thought of that. Will this actually work, though? Oops. Because it's like a generic. Oh, yeah, it does. So if hex dot starts with. Uh, okay, so it looks something like that. Then presumably we run this and we do get that answer. So let's do our own. Turn it in. Okay, perfect. Part 2, now find one that starts with 6 zeros. Okay. So that's kind of what I was talking about. It's not nearly as bad because it's only 5. It's one more. It could still take some time though. Let's try it though. And we can clean up the code in a little bit. Again, I think we'll do some refinement in a minute. Let's just try this, see how long it takes to run. Actually, that's not bad. It's only a few seconds. There we go. Okay. Yeah, so once you understand how the hasher works, that didn't feel too hard, right? That was the thing, is like it took me a little bit of time to understand how the hasher worked, and that wasn't too bad. They have similar things. I'm more familiar with doing stuff like this in Go, but they all have kind of the same flow where you have some kind of input, um, or some kind of hasher object, and then you update its values, and then you say like, okay, now give me the finalized hash. Like the reason is if you think about the hash is just like a static set of bytes, and you're feeding data into it, and it's mutating the bytes in there and bits, and eventually getting there. Okay, so how do we like maybe go about simplifying this? I mean, first of all, the code is identical, except for the fact that you are choosing between 5 or 6. So we can probably put this all in a function, right? And then we can refine the function as we need to. So we can say like pub if it doesn't need to be a public. We'll have the input stir and start stir. It's literally just going to be this. I mean, we never actually get down here, which is the funny thing, but you know, okay. So we, based on the input in the hasher, we trim, and then we look for the start. And when we finish it, so we can, this whole thing literally just becomes find hash input, and the start is 5 here, and this one is 6. It doesn't change it, does it? Okay. I mean, there you go. That maybe simplifies it a little bit. Again, you might ask yourself, like, do I have to do the format? Like, is the thing I kind of want to go down the next path is like, do I have to find the format? Can I speed it up a little bit? It's like what we're asking is, I mean, think about what the hexadecimal is doing. Like right here, right? So this is a U8. Yeah, that's what I was just counting to make sure I had this math right. But like there's 16 of these, and each of each of these are represented by 2 of these. Right? So if I wanted to get this the equivalent of like this to be zeros, it would mean the first, the second, and half of the third had to be zeros. And then if I was doing 6 of them, 1, 2, 3, 4, 5, 6, it would mean like 3 of them, right? Would have to start with zeros. So the math would, and okay, we have to do it generic. Like the idea would be changing this start. So if we do this, but we change it to find hash, no format, we can mess with it later. And instead of getting a start, we would get like a start size. And this would just be like a U size. And so we can do some math here. We can say like let zeros equal start size divided by 2. And then we'd say let left over equals start size mod 2. So this is going to tell us how many zeros we want at the front, and this is how many leftovers we want at the front. So now instead of doing this, we would say like for I in 0 zeros, if results I does not equal 0, continue. So if we don't find, so if any of the first n don't work, we want to start over there. And then we'll say if leftover I want to compare like the first half, like the largest half. So we can shift it. So we'll say let rest equal results zeros. It's a U8, so I want to like shift it 4. And then we'll say if it is equal to 0, then we can return. First time every time? How likely is that to work? Let's just do it on the first one. Find hash no format. So if we do this down here, eight. Nope, that's not it. So why would it break at 8? Uh, I kind of want to look and see what this is. Have I shifted it too much? Maybe. Is it this? Nope. Oh, I'm continuing inside this for loop. That's the issue, huh? Is that the right answer? 3, 4, 6, 3, 3, 8, 6. Okay, there you go. So this works. I don't know if this is better, right? Is it just easier to do it as a string? So what is it that I'm doing here? Sorry, I've taken a lot of time to try and optimize this hashing function. That's probably not worth it. But like normally, so I have the bytes, and the question is, can I just check to see, do I have to do this string comparison right here is the question I'm asking. So I format, I have this array of bytes. I want to format it into hexadecimal, and then I look for the hex values. I'd say, does the hex string start with 5 zeros? Well, the reality is like, the hex string would only start with zeros if there were that many zeros in it. And so you really just have, the question is okay, can I then go check and see, do I have enough zeros? This feels more complicated, especially for this problem. I suppose if you were really optimizing, you could do this. But so like what is the solution here? Basically, I'm saying look for, after I've hashed the results, I now have this array. Go look and see, do I have as many zeros as I need? And if there's a partial one, just get like the first 4 bits. That's what the shift is doing, is it's saying I have 8 bits, shift 4 away, so I only have the first half, and then check that and see if it gives me the rest. So I'm inclined to think that, I don't know, maybe this is faster than converting the whole thing to a string. Probably not, again, because the string is relatively small. I don't know. If it's a help, it's probably not that much. But I can do the same thing. Oops. Here. I mean, you can see it's still taking part 2 like a substantial amount. Feels like it's taking it even longer now. Ooh, it's not finding it. I have a bug. Yeah, at this point right here, I should also return the value, because I've gone through all of these and found all the zeros. So that's another bug in the code. 9958218. Okay, so it does give the same answer. Let's see. Do I have time on here? I don't think I'm on my Windows machine. I don't think I have a time command. Let's see how long it takes. We'd add timers here. So something like that would tell us how long it took. 1.4 seconds. And again, this is okay. So, I mean, this does say, again, this is very crude, rudimentary, but this does say that it's marginally better. The find hash no format. I'll leave it with my original solution just so you can see both of them. What other optimizations could you make? We could go down the, again, because it takes 1 second. If you're really trying to optimize, there's a potential for you to say, could we do like multi-threading? Right? Like, I presume I'm only using one CPU. Maybe this would be a fun one. Should we just see what the AI can do? So it's slow because it has to look for a value that might be in the millions. Can you add multi-threading to the function? That's a very terrible prompt. But let's just see what. Oh, I'm using GPT-4.1. Let's see what GPT-4.1 does, and then we can give like Gemini. Yeah, I'm fine with that. It's gonna use Rayon. So my guess is the way it would use Rayon is it would be in this right here, this outer for loop. And it's doing it in 100,000 chunks. Okay, let's try this, see if it works. So what is it doing? Just to be clear what it's doing here. It's doing a for loop over the chunks. And then it's doing a par iter in 100,000 chunks. Use a chunk size to avoid infinite parallel iterators. We're not. So it's going to do 100,000 chunks at a time. It's going to do the first 100,000 in parallel, the next 100,000 in parallel, and so on and so forth. So let's try this, see if it helps. Oops. Use this one right here. The first one may not be faster. Oh, I didn't tell it to use it. That's my bad. I was going to say, we'll see. The first one may not be faster just because the answer comes so fast. The effort of like setting up the parallel stuff may not Oh, that was substantially faster. Substantially faster. Okay. There's the magic of Rayon, I guess, and multiprocessing. Um, should we try it with another one? Okay, so I'm back to my original. Let's try Gemini Pro. Yeah, okay, it looks like it's doing it. Oh, you know what? Before it does this, I'm going to copy it, and we'll keep my original solution, and then we'll keep the Rayon solution in there. Okay, so what is it doing different? It's doing an infinite iterator, and it's finding any. Oh, it's even cleaned up some of my code. It's removed my initial one. So I want to keep one. No. Mm, can you do it again? I lost the code. I hate how sometimes it doesn't the interface is not intuitive. I just made a mistake there that time. That's on me. But I don't want to remove my original find hash. Yeah, so see, this is the part. Yeah, so I actually don't want to do this keep. For some reason I was thinking, oh, I'm just going to keep the 1 through 9 because I only want to apply some of them. So like this I want. This I want. This I want. This. 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 But this I don't. But it's going to be mad now. Because I need to. I feel like I made it worse. Okay. Instead of modifying my function, can you make a new Okay, one more time we'll try it. Sorry, I feel like we're now in the AI thing where I wasn't really planning to do this. I probably should have thought through how I was going to do this. But I'd like to keep my own hash, the original solution, and then this more optimized one. I do like the way this is done too, right? Is like, I guess I could have done this inline. I should have just thought that through. So we can have these instead call. Okay, so now I have all of them. I'll add this to everything so it doesn't complain. Just to be clear one more time, what's happening here is I'm doing the same thing as finding hash no format, but now we asked AI to do this and it did it in it used Rayon. And it does literally the same thing, but it's just able to do it iteratively. Okay, so let's see how Gemini's solution compares. That's wait, that's not the same answer. It's getting it wrong. That's interesting. Why would it be getting it wrong? These numbers are clearly higher and it's getting it different. So why is that? It's probably able to, it's probably checking very large. Well, let's just double check. Result zeros, iter all x equals 0. So if any of those, we return false. If leftovers, shift 4, make sure that's equal to 0. If that's the case, return true. Or here, or false. So it must be that the iterator here is like parallelizing it enough that there's like it's able to check very large numbers that also meet the criteria. Right? So it's saying, oh, I'm going to find very large numbers that also meet the criteria, but it's not finding the first one. Gemini's problem might, or sorry, the GPT one solved it, but it might not do as well just because, or it might also exhibit this issue, but it's only checking like the first 100,000 in parallel and then looping through that. And so the likelihood that two 5 zeros in the same 100,000 block is probably pretty low. And that's my guess why the other one didn't find it. So maybe you actually can't parallelize this very well. So we let's see if it can figure it out. I wonder if there's like instead of find any, there's like the equivalent of a find first. We've used Rayon before in problems, but I've always just used like the parallel iter, and it's usually like when you're doing heavy calculations. Okay, it thinks it thinks find first is a function. So if that's the case, that will probably fix it. Wow, it's much slower though. Or how do I say this? The best way to say it is it's just as slow as if I just ran it iteratively. My guess is that find first. What is by exponential blocks? Let's look at this. I'm willing to try it, see if it helps. Okay, that's a lot faster and more accurate. So did you? If you, I don't know, maybe you didn't have time. I apologize. Sometimes I'm not great about thinking what's on the screen or what's not. So what does this by exponential blocks do? It says it's dividing it into exponentially increasing size. So like the first block is maybe only 10, but the next one will be whatever 100 and then 1,000, then 10,000. And so it's going to like give blocks to those parallel bigger blocks to those parallel functions and process them in chunks. Um, that allows find first to run faster. Okay, so just to be clear, what happened? We're almost done here. We asked AI to do this for us, but we found like a subtle bug in the AI where what's happening is because it's checking for a bunch, it could find one further down the list that's not the lowest that fits the criteria and was returning that. So we moved from find any to find first, but that was nearly as slow as the previous solution. So we use this by exponential blocks just by looking here at the documentation. So praise be Rayon for their good documentation. Um, and that gave us this fine exponential blocks. And this is much faster, right? So 5 milliseconds and 94. Very good. I'm sure there's more optimizations we can do, but I think I'll leave that here. Hopefully that gives you an idea of here I am going through the process. I think like with anything, it's just like just first try and solve it. Then can we optimize it? Or maybe even do we? Right? There's an argument that I think um Eric, I believe it's his name, had now I've forgotten because I'm not in the Advent to Code mode, but has said the goal is any problem should be able to be solved on hardware from the last, I don't remember the number, 10 or 20 years, in less than a minute. So the goal is, can I just solve a problem in less than a minute? Now, you may say, oh, if it's taking more than a few seconds, maybe I want to optimize it. But based on the criteria of the puzzle, this one probably solves it. And to be honest, it's probably the most readable, right? But isn't that actually the case when you're dealing with code? Like you write it once and it feels fairly readable. And then someone says, oh, we got to go optimize it. And then it looks like this. This is much less readable, right? We could add some documentation here, right? Where we say things like, we are going to track the number of early bits we need to, sorry, I should say early bytes. We need to be zeros. If we don't have an even number, we'll want to take the first part of the next byte left over. So, oops. Oh, I don't remember how to, anyway. And then down here we could say like generate the hash. And then here we can say check to see if we got the first bytes correct. And then here we can say If we have a leftover, check it as well. And then down here we can say, if we got to this point, we don't have any leftovers and all the previous bytes were 0. So something along those lines. There you go. This would help with the readability, but again, this code definitely is much more complex than up here, right? And so as an engineer, you might say, okay, well, do I need to do this? And if you do feel like you need to do this, documentation is huge, right? I would spend a lot more time on documentation, and I would probably think about fixing some of this, right? Like you could probably put this in one line, these in one line. um, these could potentially be not this one, but this could be some kind of match or something like that. So anyway, these are just things to think about. So there you go. There's day 4 in the bag. Hopefully you enjoyed me fumbling through it. I think we actually solved the problem relatively early, but then I went off on all these tangents optimizing. So maybe that's a lesson in of itself, is solve the problem and then don't worry about it until, someone's boss's boss tells you have to optimize it, I guess. It is fun to think about, though. I will say that. I definitely think about optimizing things. So when I see something that takes 1 second to solve, especially on more modern hardware, you may say to yourself, okay, what do I need to do to improve the performance? But I will say there's been days in previous where the best solutions I could ever get to still took a couple seconds to solve, just because it did enough work that it took a couple seconds. I'm sure there maybe were better solutions to it. I just didn't know what they were. So there you go. Signing off for day 4. Hope everything is going well wherever, whenever you are. And we'll talk to you next time.